Hi everyone, and welcome to this video reviewing similarity. So we've talked about what the word similar means in class, but in this video I'm just going to go over that and go over how to tell whether two shapes are similar. So first of all, what does the word similar mean? Well, we talked about the word congruent last unit. Congruent meant the exact same size and the exact same shape. Similar is a similar word, but it doesn't matter if the two shapes are the same size. It only matters if they are the exact same shape. So when you say in geometry that two shapes are similar, it just means that those two shapes are the exact same shape. So if you're working on a problem and the question asks you, are these two shapes similar? The first thing you should do is just look at the two shapes. For example, we have these two triangles here, and to me, they look like they're the same shape. We can't tell 100% whether these two triangles are similar, but if I was asked, do I think they're similar? I would say, yes, I think they're similar because they look like they are the same shape. All right, so that's all good, but what if we want to be able to tell for sure whether two shapes are similar? Well, we've got some other pieces of evidence we can look at. First of all, we can look at the angles. So if you look at the corresponding angles of two shapes, in this case, we'll look at the corresponding three angles of the triangles, you'll notice they all match. 40 degrees corresponds to 40 degrees. They're the exact same angle. 90 degrees corresponds to 90. Again, exact same angle. And finally, 50 corresponds to 50. So one piece of evidence that two shapes are similar is if all the angles are the exact same. So all corresponding angles are equal. That tells us, yes, these two shapes are similar. There's another piece of evidence we can use as well, and that is looking at the sides. So if we look at the sides of these two triangles, we'll notice that we can match up the sides just like we did the angles. For example, 15 matches with 10, 12 matches with 8, and 9 matches with 6. And they all match, but none of them are equal. Well, for the sides, it doesn't matter if they're equal, remember, because it doesn't matter if they're the same size. It just matters that they're the same shape. But they should all be related in the same way. And this is where we'll find a ratio of the sides. So you can do this by finding the corresponding sides and dividing one by the other. So we'll take 15 divided by 10, put that in the calculator, and you get 1.5. Now we'll take another matching side, for example, 12 and 8. We'll do 12 divided by 8 equals 1.5. Starting to see a pattern. Let's do the last one, 9 and 6. 9 divided by 6 equals, again, 1.5. So we see that all of the corresponding sides, when we divide the bigger one by the smaller one, we get this ratio of 1.5. This tells us that the scale factor between the two triangles is the same. That means they're proportional. They're growing by the same amount. It's being dilated, to go back to our transformations, by 1.5. And this also is another piece of evidence that these two shapes are similar. All corresponding sides are proportional. Same scale factor. So these are three pieces of evidence we can look for to tell whether two triangles are similar. First of all, or two of any shape. Are they the exact same shape? Do they look that way? This can't tell us anything for sure, but it can give us a hint as to whether they're going to be similar or not. Second of all, if all corresponding angles are equal, then we know that they have got to be similar. And finally, if all corresponding sides are proportional, that means when you divide them, you get the same thing, in this case 1.5, 1.5, 1.5, then you know the two shapes are similar. So in this case, because of all these pieces of evidence, we know that these two triangles are in fact similar. I hope that's helpful. If you have any questions, just let me know. Otherwise, I will see you in class or in a future video.